Welcome to Science for Sleep, where wonder and calm meet. Each night we drift through galaxies, oceans, and mysteries of the natural world, not to startle, but to soothe. Somewhere beyond the reach of our own sunlight, a small traveler drifts through the dark. A fragment from another star, gliding softly through the silence we call space. Everything we know about Oumuamua. 101 Facts about Oumuamua. You will fall asleep, the drift begins. Oumuamua was first noticed in the quiet of October 2017, when telescopes scanning the Hawaiian sky caught a faint streak of reflected sunlight moving faster than any familiar body. The Pan-STARRS 1 telescope, perched above Maui, registered a pattern that made astronomers pause. The object's path cut sharply through the inner solar system, not on a looping orbit, but on a one-way passage that would never return. The discovery marked the first time humanity had observed a traveler from another star system. It was small, only a few hundred meters long, but its significance felt vast. The name chosen for it came from the Hawaiian language, Oumuamua, meaning scout or messenger reaching out first. The sound of it seemed to fit the moment. A soft word for something ancient, solitary, and moving through darkness older than the sun itself. At first it appeared as a point of light, flickering slightly as it rotated. The light curve suggested an object far more elongated than any asteroid known. Some models made it look like a cigar, 10 times longer than it was wide. Others resembled a thin, flattened shard. Whatever its true shape, it tumbled end over end, turning every 8 hours or so, brightening and dimming as its surfaces caught the sun. Its speed told another story. When it entered the solar system, it was already traveling close to 87 kilometers per second. Fast enough that no gravity here could hold it. It came in from the direction of the constellation Lyra, dipped near the sun, and then began its long climb outward, bound for the stars once again. That motion alone confirmed what astronomers quietly suspected. This visitor had not been born in our system. During its brief visit, barely 3 months of visibility, observatories around the world tried to measure every possible detail. No tail or coma was seen. Comets heat and vent gas when they pass near the sun. But this one remained silent. Its surface seemed dry and dense, perhaps coated with organic compounds called tholins, reddish substances formed by cosmic rays acting on carbon molecules over immense spans of time. Those same materials color many objects in the outer solar system, and they gave the traveler its dim, rust-red hue. Though it looked inert, its path was not purely gravitational. As it left the sun, it drifted slightly faster than physics predicted. The acceleration was tiny, a fraction of a millimeter per second squared, but unmistakable. No jets of vapor were seen, yet some invisible force was pushing it outward. Light itself might have been responsible. A body thin enough could be nudged by radiation pressure, much like a sail catching wind. Astronomers searched for radio signals, turning the great dishes of the Breakthrough Listen project toward the receding object. The receivers stayed quiet. The silence ruled out technology, but it didn't end the wonder. Even in absence, the observation carried meaning. The universe had brushed against us, and for a short moment, we had noticed. When plotted backward through space, its trajectory stretched beyond the solar boundary and into the interstellar void. For millions of years, perhaps longer, it had wandered between stars. It might have been ejected during the formation of some distant planetary system. a fragment of rock hurled outward by the gravity of a newborn giant planet. Each star in the galaxy likely sheds countless fragments this way. Only rarely does one happen to cross our path. By the time it passed Earth's orbit in mid-October 2017, it was already outbound. The closest it came was about 24 million kilometers, closer than Venus, far beyond the reach of any spacecraft we had launched. Its faintness meant that within weeks, it slipped from view, fading into the black. Yet those brief observations rewrote a chapter of astronomy. They proved that interstellar debris is not theoretical. It is real, passing among us silently. The analysis that followed lasted years. Researchers measured the spin, estimated the density, debated the cause of the acceleration. One team suggested that the body was made of nitrogen ice, a shard from a Pluto-like world. Another proposed that it was porous and light, filled with trapped hydrogen that escaped as it warmed. A few speculated it could be an object of design, perhaps a wafer-thin fragment of something once functional, long since dormant. Each idea carried both evidence and doubt, and none could be proved. What remained certain was that Oumuamua was unlike anything we had cataloged before. Its surface color, its extreme shape, its gentle boost away from the sun, and its lack of visible gas all combined into a profile that fit nowhere neatly. It was not a comet in the ordinary sense, nor a typical asteroid. It was a category of one. The years since have seen the discovery of another interstellar traveler, Borisov, a true comet with a long tail. That contrast, a dusty, active body following a scout that was silent and dry, reminded scientists how varied such visitors might be. Each one is a clue to the processes at work in distant planetary nurseries, places we cannot yet reach. Oumuamua's passing also refined the estimates of how many such objects exist. Statistically, countless fragments must be wandering the galaxy. If instruments like Pan-STARRS found one in only a few years of operation, there are likely billions more between the stars, drifting unseen. Space, though empty by measure, may be crowded with travelers. Astronomers learned that a single glimpse could transform understanding. The data gathered in those short weeks forced new models of small body dynamics, new thoughts about ejection mechanisms, and even considerations of how interstellar dust might shape itself over time. For planetary scientists, it was like receiving a sample from another solar system, one that evaporated before it could be touched. The event also revealed how quickly modern observation networks can respond. Within hours of discovery, observatories on several continents had aimed their telescopes. Within days, major space agencies and university teams were analyzing the orbit. The coordination became a template for how future discoveries might be handled, especially now that more sensitive surveys are online. Though its brightness dwindled, software continued to track its position for months, predicting its escape trajectory into the constellation Pegasus. Even now, years later, it continues outward, slowly dimming beyond the limits of our most powerful scopes. It will spend eons between the stars, perhaps passing close to another system someday, unnoticed except as a flicker in the data of some distant civilization. Its passage left behind no trail, no debris, only questions and the quiet understanding that we are not isolated. Material born around other suns drifts here, and ours in turn will drift there. The solar system breathes with the galaxy. In that sense, Oumuamua was not an intruder, but a messenger of normalcy on a cosmic scale. Planetary fragments have been trading places since before life appeared on Earth. Our technology finally became sensitive enough to see one. It is likely that, even as it departed, another was already inbound, invisible in the dark. The discovery also renewed interest in building spacecraft capable of rapid response. Ideas for interceptor missions emerged. Probes kept ready to launch when the next interstellar object is detected, able to meet it before it escapes. Engineers studied propulsion methods that could close the immense speed gap: solar sails, electric thrusters, even nuclear options. The hope is that next time we might catch up. Still, for Oumuamua, all that could be done was to watch and infer. Its story became a meditation on observation itself. How much can be learned from the faintest of signals, and how much remains unspoken? From a handful of pixels, scientists extracted measurements of shape, spin, reflectivity, and trajectory precise enough to alter textbooks. The smallness of the data contrasted with the vastness of its meaning. By the end of 2018, papers had settled on a consensus. The object was natural, though unusual. Most likely a fragment of a larger body expelled long ago. Yet the fascination persisted. Even if ordinary, it was extraordinary in what it represented. A tangible link to worlds beyond our own. As the years passed, the word Oumuamua entered both science and art. It appeared in research journals, novels, music, and poetry. It became shorthand for the unknown approaching gently, touching human awareness, then fading back into distance. Every culture leaves its own myths about messengers from the sky. This time, the messenger was real. Somewhere far beyond the orbit of Neptune, it continues to glide outward, a tiny ember against the interstellar night. Its speed now carries it away from the sun forever, adding one more faint mark to the record of things that have passed through and gone. And with that, the first chapter of its story closes. A quiet entrance, a brief crossing, and an endless departure. Yet its influence lingers. A reminder that even a speck of rock can widen the horizon of human thought. The moment of discovery. The night of the discovery began like many others on Haleakala, the quiet volcano on Maui where the Pan-STARRS telescope keeps watch. The dome opened slowly as twilight faded, revealing a sky so clean that even distant galaxies shimmered faintly. For the astronomers running their automated survey, it was routine. Hundreds of images captured and compared, looking for motion among the stars. But in that stillness, one moving point appeared that did not belong. At first it seemed ordinary, another small asteroid drifting through the main belt. Yet when the coordinates were entered into the Minor Planet Center's database, the orbit came back wrong. Its path was not an ellipse circling the sun. It was a hyperbola, an open curve that would never close. The object had come from interstellar space, looped around the sun, and was now leaving. It was the first time an equation had so clearly told a story of something from beyond. Astronomers named the object temporarily as A 2017 U1. The A indicated it was not a comet, and the numbers placed it late in the year's sequence of discoveries. But as data accumulated, the name began to feel too small for what it represented. Within days, the International Astronomical Union approved a new designation, 1I Oumuamua, where I marked it as the first of a new class, Interstellar. News spread through observatories and journals with the quiet shock that accompanies a genuine first. Humanity had waited centuries for proof that fragments from other star systems could reach us. And here it was, slipping past unnoticed until it was nearly gone. By the time confirmation came, the object had already rounded the sun and was receding fast. The opportunity to study it was shrinking hour by hour. The Pan-STARRS telescope measured its brightness and color, while researchers at other observatories refined its orbit. The Canada-France-Hawaii telescope captured additional images, while the European Southern Observatory's Very Large Telescope gathered spectra, the fingerprints of reflected sunlight. Those faint lines revealed that the surface was reddish, similar to objects found in the outer reaches of our own system. Cosmic rays had darkened and carbonized its surface over millions of years, a kind of aging that spoke of immense travel through radiation and cold. The object's rotation added another layer of intrigue. Its light fluctuated every few hours, showing that it was spinning chaotically. No regular axis, no predictable pattern, just a slow, tumbling motion, unlike the steady rotation of asteroids, shaped by collisions. That tumble might have been caused by some ancient impact before it was thrown free of its home system. The uneven rotation also meant that sunlight heated it irregularly, perhaps leading to the subtle acceleration observed later. Scientists compared its apparent dimensions to known objects. If its brightness reflected a typical rocky surface, it could be around 200 meters long and 20 meters wide, 10 times longer than it was thick. That extreme proportion was unprecedented. Some comets elongated as they shed mass, but nothing this much. Others suggested it might be thin, like a flake or pancake, which would explain the way sunlight seemed to push it outward. In the weeks that followed, models were drawn, simulations run, and debates began quietly under the dome of every observatory that had seen it. The small details from those first nights became foundational. Its trajectory, recorded precisely, entered the archives. A path from Lyra to Pegasus, a graceful curve through the inner solar system. The orbit crossed above the plane of the planets, missing Earth by a comfortable distance, but passing close enough that its presence felt strangely personal. A visitor from the unknown that came within reach but could not be touched. Though it was gone within weeks, the implications lingered. Its discovery meant that interstellar objects are not rare. For such a body to appear in a limited survey window suggested that countless others drift between the stars. Some are likely small, others vast, some silent, some active with frozen volatiles that might glow as they approach new suns. The solar system, once thought isolated, was revealed as porous. As scientists reconstructed its journey, they estimated that it had been traveling freely for hundreds of millions of years. Perhaps it was ejected when planets formed around another star, young worlds colliding, throwing fragments into space. Each fragment would then wander alone, cold and inert, until chance drew it near another system. Over the lifespan of the galaxy, such meetings must happen continuously, unnoticed. Oumuamua's trajectory suggested it had not been heavily perturbed by encounters with other stars during its voyage. That stability implied it had spent vast stretches of time in empty interstellar space, untouched by gravity strong enough to alter its course. The smoothness of its path became a map of galactic quiet, an invisible trail through distances where even dust grows rare. Its close pass by the sun provided data that extended beyond the object itself. Astronomers used its behavior to refine models of how solar radiation and gravity interact on small bodies. They learned how little sunlight it took to influence motion over millions of kilometers. These insights would later shape the designs of solar sail experiments and deepen understanding of comet dynamics. For planetary scientists, the event became a case study in cosmic timing. The detection came only because Earth's technology had finally reached the right sensitivity. Just a decade earlier, telescopes would have missed it completely. Pan-stars had been built to scan the skies for potentially hazardous near-Earth asteroids, taking repeated images every night. Its automated comparison software flagged moving objects, but the system had not been designed to catch something from beyond. Yet it did, and in doing so, it opened a new era of observation. Within a few days of the discovery, the Minor Planet Center distributed an alert to observatories worldwide. Calls and messages passed between astronomers in Hawaii, Arizona, Europe, and South America. For a brief time, a global network worked in harmony, chasing the faint light of a foreign stone. Every observation added precision to its orbit, sharpening the understanding of its origin. Its hyperbolic eccentricity, the measure of how open its path was, turned out to be about 1.2, far greater than any known solar system body. That number alone proved it was unbound, moving too fast to ever return. Calculations showed that after leaving the influence of the Sun, it would continue toward the constellation Pegasus at roughly 26 kilometers per second, relative to the stars, slowly dimming into infinity. Even as data flowed in, telescopes struggled to keep up. Each night it grew fainter, the sunlight reflecting from it less and less. Within a month, even the largest instruments could barely detect it. By January 2018, it had vanished from view entirely. Yet its impression lingered, like an afterimage in the collective gaze of astronomy. The experience reshaped how observatories planned their searches. Instruments capable of scanning wide fields would henceforth include algorithms to spot objects with highly unusual velocities. Researchers also began considering how to recognize interstellar visitors earlier, perhaps months before they neared the Sun. The hope was that the next one could be studied in greater detail, or even intercepted by a spacecraft. While the data on Oumuamua were limited, they contained layers of meaning. The absence of a visible tail challenged assumptions about what happens to icy bodies near a star. The color spectrum hinted at organic compounds. The non-gravitational acceleration demanded new physics within familiar boundaries. Each clue was small, but together they told a story of complexity in simplicity. A single object carrying within it the fingerprints of an entire system's history. To study it was to confront scale, distances beyond human intuition, time spans measured not in years, but in ages. The object had existed before our Sun was halfway through its life, and it would continue long after the Sun itself had dimmed. Its discovery placed human observation within that vast continuum. In retrospect, the moment of discovery feels almost quiet. No spectacle, no bright comet tail. Just a flicker in the data that turned out to be the first solid thing ever known to have come from another star. It revealed that the boundary between our space and theirs is not a wall, but a veil. Through that veil, matter passes silently, carrying the memory of distant suns. As the international papers began to publish their analyses, a pattern of cautious wonder appeared. Astronomers spoke of it as a messenger, though not in mystical terms, a messenger of probability, of cosmic exchange. The galaxy, they realized, constantly trades its materials, scattering seeds of planets and moons across interstellar distances. The same forces that created Oumuamua must have ejected billions more. Some might have crashed into young worlds elsewhere, seeding chemistry or shaping craters that one day other beings might study. In that sense, son, the discovery was more than a single event. It was an affirmation that the universe is dynamic and open. What we saw that night in October 2017 was not an exception, but a reminder of connection. A fragment of elsewhere passing through, unannounced, indifferent, and beautiful in its transience. The visitor from afar. In the months following its departure, the image of the traveler lingered in minds and journals alike. Not as a photograph, but as a question. What was it, truly? The shape was guessed, the path was known, yet the substance remained uncertain. Its faint reflection was all anyone had, and from that reflection, an entire library of possibilities began to unfold. Scientists across the world examined the data that had been gathered. They replayed each observation, plotted each rotation, compared the brightness patterns to known comets, asteroids, and icy fragments. The more they compared, the more singular Oumuamua seemed. It shared some traits with rocky asteroids, the lack of a visible coma, a consistent reddish hue. Yet its motion and acceleration did not fit neatly anywhere. The term interstellar held a weight of mystery. Until then, all space rocks had been born of our own sun's gravity. Oumuamua was different. It had drifted through galactic emptiness for perhaps 500 million years, its surface slowly sculpted by cosmic rays and micrometeorite impacts. It was both ordinary and miraculous, a piece of the universe's debris, and the first we had ever noticed passing through our neighborhood. To imagine its journey is to picture a silence so deep that even light travels like a whisper. Long before Earth's first forests grew, this object may have been flung from a young planetary system forming around a distant star. Perhaps a collision had shattered a growing world, or a close encounter with a gas giant had hurled fragments into the void. In that chaos, a single shard found escape velocity, entering a path that would wander between stars indefinitely. Across millions of years, it crossed the interstellar medium, that thin ocean of hydrogen and dust, its surface darkening, smoothing, and hardening. Radiation stripped away volatiles, leaving behind a shell of carbonized material. Inside, perhaps, was stone or metal, or remnants of frozen gases long vanished. By the time it entered our solar system, it was ancient beyond imagining, a witness to epochs no telescope could ever see. When it arrived, it carried with it physical signatures of that long journey. Its reflectivity was low, meaning it absorbed most of the sunlight that touched it. Its density appeared high, suggesting little internal ice or voids, unlike typical comets, which brighten dramatically as they near the sun. Oumuamua's luminosity remained subdued, as though its material was sealed tight against heat. One hypothesis proposed that it was composed of solid hydrogen or nitrogen ice, so pure that sublimation would be invisible. If sunlight warmed it just enough to cause slow outgassing, the escaping molecules could provide a tiny thrust, explaining the acceleration without creating a visible tail. The idea was elegant, but uncertain. No direct evidence of hydrogen or nitrogen was found, and such a material might not survive eons in interstellar space. Another school of thought considered the possibility of radiation pressure, the push of sunlight itself. If the object were thin, perhaps only a fraction of a millimeter thick, photons could impart a measurable force. This led to the bold suggestion that Oumuamua might be a natural light sail, a fragment of material shaped like a sheet, reflecting light across the galaxy. In this vision, it wasn't an engineered craft, merely a relic of cosmic geometry, something formed naturally, yet behaving as though designed. The discussion broadened when the physicist Avi Loeb proposed that it could, in fact, be technological, an artifact from another civilization. His reasoning was not that of science fiction, but of anomaly. The unusual acceleration, the lack of gas, the precise trajectory. Perhaps, he argued, it was debris from some long-vanished civilization, drifting as our own satellites might someday drift through other systems. The notion drew both curiosity and skepticism. Most astronomers preferred simpler explanations: natural forces, subtle outgassing, optical effects. Yet the debate itself revealed the moment's wonder. For once, humanity could speak of another world's object in the same breath as its own. The visitor's ambiguity became a mirror for human imagination. What could be said with certainty was that Oumuamua's path confirmed the existence of interstellar wanderers. It also provided data on how the galaxy exchanges its matter. Every star system, during its early formation, ejects countless fragments: icy comets, rocky shards, metallic dust. Over time, these fragments drift freely, crossing the vast distances between suns. The Milky Way, once pictured as a collection of isolated stars, is instead a slow river of shared material. Our own solar system contributes to it, flinging its debris outward through gravitational encounters. When Oumuamua entered our neighborhood, it moved with the speed expected of galactic drift, about 26 kilometers per second relative to nearby stars. That speed placed it among the slowest interstellar travelers we might expect. Not a rogue projectile, but a quiet stone keeping pace with the Milky Way's rotation. Its entry direction suggested it came from near the galactic plane, the dense mid-region where most stars reside. If traced backward, it passed within a few light years of several star systems millions of years ago. But none could be identified as its home. Its visit, brief as it was, inspired new ways of thinking about time. When we look at planets, we see cycles, orbits, returns, repetitions. Oumuamua broke that rhythm. It came once, moved through, and left forever. Its very presence was a reminder that not everything returns. In cosmic terms, it was a letter dropped in transit, read only because chance let it fall across our gaze. Even as telescopes lost sight of it, computers kept modeling its shape and spin. The tumbling motion, irregular and unstable, was unique. Normally, rotational energy dissipates over time as an object settles into a stable spin. The fact that Oumuamua continued to tumble suggested it had not collided or been torqued significantly since its ejection. That stability was another marker of its age. It had traveled undisturbed through calm interstellar seas for unimaginable durations. Comparisons to known comets and asteroids highlighted its strangeness further. Most small bodies are bound by gravity and have compositions dominated by either rock or ice. Oumuamua's apparent density and dryness made it more like a rocky asteroid, yet its acceleration mimicked cometary behavior. It was a hybrid, a category unto itself. Some papers coined the term exocomet fragment, a leftover piece from another system's outer regions, reshaped by time and stripped bare. These ideas were tested through spectroscopy. The reflected light contained subtle clues. An absorption feature near 0.7 micrometers hinted at complex organics, while the absence of emission lines confirmed no active gas. The surface temperature during its perihelion, around 330 Kelvin, was warm enough to vaporize water ice, yet none was seen. Whatever it was made of, it resisted the sun's heat. This resilience led some to imagine that its crust might be coated with a dense layer of carbonized material, several millimeters thick, a shell that trapped any remaining volatiles within. If occasional pockets of gas did escape, they would do so invisibly, providing the slight acceleration without visible trails. The explanation was not perfect, but it felt consistent with nature's tendency toward subtlety. Beyond science, there was symbolism. For centuries, humanity had imagined messengers from other worlds, comets as omens, meteors as signs. Oumuamua, quiet and indifferent, fulfilled those myths in a different way. It was no portent, only presence. A stone among countless stones, yet it carried the weight of being the first confirmed visitor. Its passing was not dramatic. It was gentle, almost secretive, like a whisper of the galaxy acknowledging itself. The interstellar medium it crossed between systems is almost a vacuum, but not entirely. Over millions of years, its surface would have collected atoms of hydrogen, traces of dust, even the occasional cosmic particle strike that left microscopic craters. Each mark was a record of time longer than the existence of our species. If one could hold it, the surface would be smooth, yet pitted, cold beyond measure, older than memory. The visitor from afar thus became a symbol of endurance, a fragment that survived the birth and death of stars, traveling unclaimed through infinite dark. Its discovery did not end mystery. It expanded it. After Oumuamua, every faint point of light on a hyperbolic trajectory would invite the same question: what world did it leave behind? By the following year, new surveys were planned with this question in mind. Instruments like the Vera C. Rubin Observatory were designed to scan wider and deeper than pan-stars, promising to find many more such objects. The excitement was quiet, but profound. We had glimpsed one, and that was enough to know there must be others. In time, perhaps, one of those others might linger longer, slow enough for a spacecraft to meet it. Projects like the proposed comet interceptor began as direct descendants of Oumuamua's passage, conceived to wait patiently in orbit, ready to chase the next interstellar visitor. Though it may never be seen again, the first traveler continues to teach through its absence. Its name now appears in textbooks and lectures, its orbit mapped in software, its story recited as both science and metaphor. It reminded us that the universe is not composed of distant, sealed systems, but of exchange, endless migration through emptiness. As years passed, Oumuamua faded from view, but not from thought. It remains a quiet echo of possibility, drifting onward beyond Pluto's orbit, beyond the heliopause, into regions where the sun's influence wanes and the stars of other systems begin to dominate. Its course is unchanging, its spin eternal until chance or collision alters it once more. Somewhere far ahead, it moves now through the thin light between stars, an ember from an unseen fire, a visitor from afar, continuing endlessly into the dark. The shape of mystery. Even after its departure, astronomers lingered on the question of what Oumuamua actually looked like. There was no photograph, no resolved image, only the shifting brightness of sunlight glancing across its surface as it spun. From that faint flicker, they tried to build a picture. The object brightened and dimmed more dramatically than anything of its size ever recorded. Its light curve changed by nearly a factor of 10 as it rotated. For an object reflecting sunlight, such variation could mean only one thing. It was extremely elongated or oddly flattened. The ratio of its length to its width was estimated to be at least 5 to 1, perhaps as high as 10 to 1. Nothing in the asteroid belt shared such proportions. Some modeled it as a slender cylinder, others as a wide, thin disk, like a skipping stone turning and flipping through the void. Both shapes could match the data if they tumbled irregularly. The tumbling itself added to the enigma. Most asteroids and comets eventually stabilize into a single axis of rotation. Collisions and internal damping slow their chaotic motion over time. Oumuamua, by contrast, showed no sign of settling. It seemed to spin around multiple axes at once, in a pattern that would continue indefinitely unless disturbed. That chaotic rotation hinted at its history. It might have been struck or pulled apart long ago, thrown into space by the violent birth of a star system. Over the ages, its irregular shape preserved the memory of that event. The light reflecting from it, when plotted against time, produced a rhythm that was uneven yet strangely graceful, as though it were turning in a slow dance choreographed by chance and gravity. To measure it was to chase a shadow. The brightness curves arrived as numerical columns, not images. Astronomers converted them into models, spinning virtual bodies under simulated light. Each version produced a slightly different outline, a cigar, a blade, a chip. But all agreed on one feature. This was no sphere, no simple lump of rock. The faintness of the object meant that even the world's largest telescopes could not see detail. Its angular size from Earth was smaller than a pixel. Yet from that pixel, scientists extracted volumes of knowledge. Rotation period, albedo, even surface color. The object's reflectivity was low, about 10%, similar to carbon-rich material found on outer solar system bodies. The red hue indicated long exposure to cosmic radiation, which darkens and carbonizes the surface. The combination suggested a hardened shell, possibly insulating any volatile core from sunlight. If that shell existed, it explained much. When a comet approaches the sun, frozen gases beneath its surface vaporize, producing jets that push it slightly off course. Those jets create visible comas and tails. In Oumuamua's case, nothing was seen, but the trajectory still shifted. A sealed crust could have allowed small amounts of trapped gas to escape through microscopic cracks, providing a gentle thrust too faint to form a visible plume. The physics matched the observed acceleration precisely. Some argued instead that radiation pressure alone could do the work. If the body was thin enough, a few millimeters thick, sunlight could provide enough push to account for the change. That idea led to poetic speculation. Perhaps it was a fragment of something broader, a wafer torn from a larger sheet of material, drifting for eons until it crossed our path. Whether natural or not, such a form would represent a new kind of object in our understanding of planetary debris. The uncertainty over its true shape became symbolic. It reminded scientists how much could be inferred from so little and how much still remained hidden. The data were clean, the models elegant, but no model could claim certainty. Each possibility left unanswered questions about composition, density, and origin. Further insight came from polarimetry, the study of how light waves align when reflected. Measurements suggested that the surface was smooth and compact, not porous like typical comet dust. That smoothness implied that Oumuamua had been shaped and polished by radiation and micro-collisions during its long interstellar voyage. A rough, irregular object would scatter light randomly. A smoother one would create the specific polarization angles observed. The tumbling motion, analyzed through those angles, indicated that it rotated roughly every 7.3 hours, but with a complex precession that made the period appear variable. This irregularity produced the illusion of a heartbeat in its brightness, a slow pulse across the sky that repeated without rhythm. Observers described it as hauntingly beautiful, a distant glimmer waxing and waning, as though breathing in the dark. Because its motion could not be tied to any known cometary jets, scientists revisited older ideas about interstellar fragments. Some proposed that it might be a piece of a planet's crust, ejected when that world collided with another. A shard of continental rock could easily take on an elongated form. Others imagined it as a relic of a tidally disrupted comet, stretched and hardened by the forces of a passing star. Both scenarios fit the mathematics. Neither could be proven. Each hypothesis told a different story of violence and endurance. In every one, Oumuamua was a survivor, a remnant of formation and destruction, carrying the physical memory of a world we will never see. It had wandered through environments where temperatures dropped close to absolute zero, where ultraviolet radiation struck unshielded for millennia, where gravity's pull was a gentle whisper instead of a grip. Over time, any trace of its birthplace would have been erased, leaving only a hardened mineral core sealed beneath radiation-burned layers. The lesson was humbling. Even without direct images, careful measurement of light could reveal structure, texture, and movement. The study of Oumuamua became a masterclass in inference. Astronomy at its most delicate, where knowledge emerges from hints and patience. Scientists realized that the same methods could be used to study other faint interstellar objects once they were found. The object's peculiar shape also raised new questions about how light interacts with irregular bodies. As it tumbled, its brightness didn't vary symmetrically, suggesting that one side reflected more efficiently than the other. That asymmetry might mean a difference in surface composition, or a curvature that focused sunlight unevenly. In numerical models, a slight bend or ridge along its surface reproduced the observed curve exactly. If that ridge existed, it could have formed from melting and refreezing during close passes by other stars long ago. Every theory hinted at a history longer than the solar system itself. To contemplate it was to feel the scale of cosmic time, to imagine matter moving through billions of years, shaped by chance encounters and the slow erosion of light. Oumuamua's shape thus became more than a geometric problem. It was a narrative of resilience. Its odd proportions told of the processes that sculpt the universe on every scale: collision, erosion, radiation, and motion through emptiness. The traveler's mystery reminded us that simplicity in observation does not mean simplicity in nature. By the end of the first wave of research, consensus had softened rather than hardened. No single description satisfied all data, yet each attempt added a layer of understanding. The cigar shape, the disc shape, the flake, the fragment, all remained viable portraits, of the same elusive subject. The most that could be said with confidence was that the object was highly elongated, reddish, tumbling, and small, a handful of light against an infinite dark. It was, in its way, an object lesson in humility. The limits of perception became part of the discovery itself. What could not be known was as meaningful as what could. And so the shape of mystery lived up to its name, a form half inferred, half imagined, gliding silently through the pages of scientific record, leaving behind equations, debates, and a quiet sense of wonder. The sound of silence. Silence can speak louder than any signal. When Oumuamua crossed the inner solar system, it left behind no glow, no hiss of vapor, no spark of radio noise. Its stillness became a form of data, a negative imprint as valuable as any measurement. In the first days after its discovery, the world's great radio telescopes turned their ears toward it. The Allen Telescope Array in California, the Green Bank Observatory in West Virginia, and the enormous dish at Jodrell Bank in England all joined in. Their aim was not sensational. They were following routine protocol. When something so unusual entered our system, it was sensible to listen. For weeks, receivers scanned across multiple frequency bands, searching for any narrow, repeating tones, the kind that nature rarely makes on its own. There was nothing. No carrier wave, no pulse, only the constant background hum of space. The data, while quiet, were precise. If the object had been transmitting with even a fraction of the power of our own spacecraft, the signal would have been detected. It was silent, and therefore almost certainly natural. That absence of sound carried its own serenity. In a universe full of radiation and movement, true silence is rare. The visitor from another star passed through us without disturbing the stillness, a moving shadow across the vast background noise of creation. Astronomers realized that this lack of emission held meaning. If Oumuamua contained metals or electronics, it would have reflected radio waves in a particular way. Instead, it behaved like stone and carbon, materials that absorb more than they echo. Its quietness confirmed that it was not metallic, not hollow, but solid and inert. While the telescopes listened, optical observatories continued to trace its path. The orbit remained smooth, its acceleration consistent with the slight pressure of sunlight or invisible outgassing. That consistency became another kind of silence. No sudden shifts, no erratic motion, nothing to suggest activity or control. In a cosmos where every body follows gravity's voice, Oumuamua drifted obediently to physics alone. This quiet also extended to light. Spectroscopic measurements revealed no emission lines, the signatures of gases fluorescing under solar radiation. The traveler reflected sunlight without adding any of its own. No sodium glow, no carbon jets. It was a dark mirror, reflecting only what it received. For planetary scientists, that stillness told a story about composition. A body that does not vent gas when warmed must be sealed, its volatiles buried deep or gone entirely. Its reddish surface, shaped by cosmic rays, acted like a shell, the outer bark of a tree long dead but still drifting through time. Beneath that shell, minerals could remain unchanged since the dawn of its home system. In that sense, silence was preservation. The Breakthrough Listen project, which had been established to search for extraterrestrial signals, dedicated part of its observing schedule to the object. The team at Green Bank collected terabytes of data across billions of frequencies, then combed through them for patterns. None emerged. The analysis took months, but the conclusion was as steady as the stars. The silence was absolute. Yet the story of listening was not one of disappointment. The quiet had its own poetry. It reminded researchers that most of the universe communicates through gravity and light, not words or signals. The traveler spoke in reflection and motion. Its orbit was a sentence written in geometry, its silence a pause filled with meaning. In that pause, human imagination worked freely. Writers, musicians, and artists responded to the discovery in their own mediums. Some composed symphonies inspired by the idea of an interstellar visitor too quiet to be heard. Others wrote essays and poems about the meeting of cosmic solitude and human curiosity. The scientific silence became an emotional resonance, echoing through culture as softly as the object itself had passed through the sky. There was also a practical lesson in the absence of sound. It reminded astronomers of the fragility of detection. How many such objects must have come and gone unseen simply because they made no noise? Our instruments are tuned to what shines, what emits, what roars. The universe, however, contains far more that glides unseen and unheard. Oumuamua demonstrated that interstellar space is not empty. It is filled with quiet travelers beyond the reach of light or radar. This realization reframed the search for interstellar matter. Instead of waiting for bright comets or dramatic impacts, astronomers began to consider the invisible, the faint, silent fragments crossing the solar system every few months. Most are too small to detect. Some might pass between Earth and the Moon without a trace. The data from Oumuamua showed that these objects could carry chemical and mineral signatures from distant systems, making them messengers not of sound, but of material exchange. To measure silence is to measure context. When the radio rays turned off, researchers looked again at what they had learned indirectly. The visitor's albedo, its reflectivity, indicated a surface smooth enough to scatter light evenly, but not glossy. Its rotation produced no changes that would suggest venting or flaring. Even the lack of polarization shifts in its reflected light suggested uniformity. Every aspect of observation said the same thing: calm, steady, unchanging. From that steadiness, models emerged of what such a body could be made from. Dense compound-san, carbon-rich minerals, possibly mixed with silicates. Perhaps the fragment of a planetary crust. Maybe a piece of an icy world whose surface had been baked and sealed over eons. In any case, the traveler was inert, a record of formation, not an active participant in its own journey. Astronomers often describe comets as singing, the term for oscillations produced when sublimating gases vibrate through their surfaces. Oumuamua did not sing. It passed through in a silence so deep it bordered on reverence. In that quiet, science found new patience. Observation became an act of listening to nothing and learning everything from the lack of reply. Even when models grew fanciful, the data never contradicted the simplest truth. It was quiet because it had nothing left to say. No internal heat, no atmosphere, no magnetic field. The energy it reflected came entirely from the sun, filtered through the scarred surface of a body aged beyond counting. By late 2018, the object had faded beyond detection. Radio telescopes returned to their normal surveys, and optical instruments pointed elsewhere. But the silence endured in the archive. Thousands of hours of data containing no signal, no pattern. only the cosmic background. That quiet archive became a baseline for future searches. If another interstellar object arrives and hums faintly at any frequency, it will stand out against Oumuamua's perfect stillness. Silence can be comforting. It can also be profound. In the case of Oumuamua, it bridged the gap between mystery and certainty. By saying nothing, it revealed itself. Natural, ancient, indifferent. The absence of a message was, in its way, the clearest message possible. And so, the sound of silence became its final note in the scientific symphony. Not a signal received, but a truth understood. That the universe, vast and cold, speaks quietly most of the time. We just have to learn how to listen to what is not there. The cosmic context. By the time the last traces of Oumuamua's light disappeared into the noise of the sky, astronomy had already changed. The single object had rewritten expectations about what might drift between the stars and how often we might see one again. For centuries, comets and asteroids had been the domain of solar dynamics, material bound to the sun's family. Now the boundaries were open. The discovery prompted a quiet rethinking of the solar system itself. It was no longer an isolated island of matter, but part of a flowing sea. A system immersed in a galactic current of wandering debris. What had once been imagined as static turned out to be porous. The gravitational borders of the sun were only temporary thresholds crossed by ancient travelers. The first sign of that new perspective came in 2019 when telescopes detected another interstellar visitor. This one was unmistakably a comet, trailing a bright tail and a halo of dust. Named Borisov after the amateur astronomer who discovered it, it confirmed that Oumuamua was not an anomaly. Interstellar objects were real, and at least some resembled the icy bodies born in our own system. Borisov's composition resembled that of familiar comets: water ice, carbon monoxide, and dust. But its trajectory and speed marked it as a foreigner. The contrast between Borisov and Oumuamua revealed the diversity of materials drifting through interstellar space. One object was dry and silent, the other bright and volatile. Together they formed the first faint sample of the galaxy's debris. Astronomers began to estimate how many such visitors must exist. The numbers were staggering. For every star, trillions of fragments might have been ejected over billions of years. The Milky Way could contain more free-floating debris than stars. Most would be small, dark, and invisible to our telescopes. But a few, like Oumuamua, would pass close enough to be seen. Statistically, a new one should enter the inner solar system every few years. This realization shifted focus from rarity to preparation. If interstellar objects were common, then they could be studied systematically. If we were fast enough. Missions were proposed that could launch on short notice, waiting in readiness until the next alert. The European Space Agency's Comet Interceptor, planned for the late 2020s, was one of the first designed with this flexibility in mind. It would wait in space, dormant, until a suitable target, perhaps another traveler from beyond, appeared. The story of Oumuamua also influenced how astronomers thought about planetary formation. Each system's early years are violent. Disks of gas and dust coalesce into worlds, collisions reshape surfaces, and gravity ejects the excess. The material that escapes becomes interstellar rubble, wandering indefinitely. By studying these wanderers, scientists could indirectly study the processes that shape distant stars' planets. Every fragment carried chemical signatures of its birthplace, the fingerprints of alien geology. The object's non-gravitational acceleration, once puzzling, became a test case for modeling how sunlight and heat affect small bodies. Its faint boost away from the sun provided constraints on how reflective or porous its surface must be. Researchers discovered that even a thin crust of carbonized ice could behave like a sail under the gentle push of photons. Such insight fed directly into spacecraft design. The concept of using sunlight for propulsion, once theoretical, now had a natural example. In educational settings, Oumuamua's story became a gateway to larger questions. Teachers used it to illustrate orbital mechanics, the scale of interstellar space, and the limits of observation. Students calculated escape velocities, light travel times, and the energy required to match its speed. Through numbers and geometry, they glimpsed the enormity of what it meant for an object to come from elsewhere. The cosmic context also included a cultural one. Humanity had sent its own messengers outward, the voyagers, pioneers, and new horizons, all now leaving the sun's domain. Someday, in the far future, those spacecraft will drift into other systems as anonymous artifacts. To another civilization, they might appear much like Oumuamua appeared to us. A silent shape moving through darkness, a mystery of origin. The symmetry was poetic. What we observed was what we would eventually become. Scientists often spoke of the galactic ecology that such objects represented. Matter is not confined. It circulates. The heavy elements forged in stars are spread by supernovae, gathered again into new planets, broken apart by collisions, and sent drifting once more. Oumuamua was part of that endless exchange, a single grain in the galaxy's long conversation of matter and motion. This view also reframed the search for life. If planetary materials mix across star systems, then the ingredients of biology are widely shared. Organic molecules can ride on fragments between suns, spreading chemistry through the galaxy. The idea, known as panspermia, gained subtle support from the realization that such transfer is not rare. A microbe or a molecule could, in theory, survive the journey sealed inside a rock like Oumuamua. At the same time, the object's singularity reminded scientists of the fragility of evidence. It was observed for less than 2 months, with instruments never designed for such distant, fast-moving targets. The data were excellent, but incomplete. Every conclusion carried uncertainty. In that uncertainty lay opportunity, the drive to build better eyes on the sky. Next-generation surveys, like the Vera C. Rubin Observatory's Legacy Survey of Space and Time, promised to revolutionize detection. With its wide field and constant scanning, it would catch many more interstellar visitors each year. Each discovery would refine statistics, constrain models, and perhaps one day reveal an object while it was still inbound, allowing direct observation before and after its passage. The cosmic context also had a philosophical layer. Oumuamua reminded humanity that, even in the vastness of space, paths intersect. The solar system's orbit around the galaxy, combined with the motions of other stars, ensures that our neighborhood is never truly alone. Every few decades, fragments from other worlds brush past, unseen. The distances are unimaginable, yet the encounters are inevitable. For astronomers who spent their careers studying orbital mechanics, the equations took on new emotional weight. The mathematics that describe a hyperbolic trajectory became a story of meeting and parting. The constant of gravity turned into a metaphor for connection. Oumuamua's brief visit embodied the transient nature of cosmic relationships. Crossings measured in days, separations measured in eternity. The event also sparked collaboration beyond the scientific community. Writers and philosophers reflected on what it meant to witness something so ancient and indifferent. Some saw it as a reminder of humility, humanity's awareness extending only as far as its instruments allow, yet still able to touch the infinite through observation. Others saw hope, that the universe is not closed, that exchange and contact, even silent, are part of its design. In research circles, the visitor's name became shorthand for an entire field of study. Papers on future interstellar detections now carry titles referencing it. The Oumuamua effect describes how unexpected discoveries reshape scientific priorities overnight. Budgets were adjusted, collaborations formed, and instruments retooled, all because of a single streak of light across a telescope's field of view. Years later, when Tui Borisov completed its pass and faded, scientists compared the two trajectories. They formed the beginning of a statistical curve, the first data points in a graph of interstellar object frequency. From these, the community could finally begin to quantify how common such events are. The answer was reassuringly large. Interstellar objects are plentiful. Our awareness of them is what had been rare. In that realization lay the final context, a sense of belonging. The solar system, the Milky Way, the travelers drifting between them, all are parts of the same continuum. The emptiness between stars is not barren. It is connective tissue, a medium through which fragments, light, and perhaps ideas move. Oumuamua's crossing simply made that truth visible for the first time. The push that shouldn't be. There are moments in science that arrive not as noise, but as stillness. After the calculations were done, after the orbit was drawn, one gentle deviation remained, a motion too soft to call a mystery, yet impossible to ignore. Oumuamua was drifting away from the sun, slightly faster than gravity alone could allow. It was as if light itself had reached out and given it the smallest of nudges. The acceleration was delicate, almost tender, the kind of shift that would move a feather rather than a stone. Numbers described it, but the numbers themselves felt quiet, like distant ripples on calm water. The object continued on its path, unharmed, unhurried, gliding through the shallows of the solar system toward the open dark beyond. Astronomers debated causes, but their voices were soft with awe. Perhaps sunlight pressing gently on its surface was enough. Perhaps invisible gas escaped through pores too small to see. The equations could fit either answer, and both explanations were beautiful in their own way. What mattered most was not which was correct, but how subtle the universe could be, how even the faintest force could carry something across eternity. In the grand machinery of the cosmos, there are storms, collisions, explosions beyond imagination. Yet here was the opposite, movement born from gentleness, a whisper of radiation guiding a traveler between the stars. Over time, the conversation about its motion softened into contemplation. If light could push this small fragment, then light was not merely illumination. It was a wind, a current flowing endlessly from every star. In that current, even the smallest things drifted slowly toward forever. The idea felt peaceful, almost meditative. A galaxy breathing, each photon a quiet exhale. As it moved farther from the sun, Oumuamua entered cooler, calmer regions of space. The sunlight grew pale, the warmth faded, and the visitor's long spin slowed almost imperceptibly. Its path was now fixed, open, eternal. The solar system fell behind, like a dream receding at dawn. The scientists who tracked it began to close their studies. They would publish what they knew, and they would never see it again. But for a while longer, the data still arrived. Points of light, faint but steady. Each one told the same story. No tail, no sound, only that small, graceful acceleration, still there, still unbroken. The mystery of the push that shouldn't be became a lullaby of possibility. It reminded humanity that understanding is not always an act of control. Sometimes, it is simply the act of noticing that something moves differently and allowing wonder to exist beside knowledge. Light continued to fall across the Voyager's surface. The red tones of its crust deepened. The texture roughened as particles of dust drifted past. Each moment grew quieter, and the object slipped beyond the reach of all instruments. What remained was thought, imagination, and a feeling that somewhere, something small was still moving through darkness, guided by nothing more than a touch of light. And in that thought, sleep comes easily. A quiet assurance that even across impossible distances, gentle forces persist. That not all motion is struggle. That sometimes the universe moves softly, carrying everything within it toward peace. The voice of scientists. In the months after Oumuamua vanished from view, the world of science became strangely still. The excitement that had once pulsed through research papers and observatories now settled into something quieter. Not disappointment, but reverence. For those who had watched its fleeting light, the feeling was like remembering a dream, vivid, important, but already drifting away. Researchers gathered in small meetings in quiet conference halls. There were charts and slides, but their voices were soft, measured, contemplative. They spoke of reflectivity and motion, but beneath the numbers ran something else. The awareness that they had glimpsed something utterly singular. Every question they asked seemed to open into another, larger one. No one raised their voice. There was no argument, no final conclusion, just gentle wondering, like ripples fading on still water. They called it the first interstellar object, but privately, some thought of it as a visitor, a brief presence that had changed how the sky itself felt. One astronomer described the discovery as the universe whispering. Another said, it reminded us that the cosmos is alive with quiet motion. In their papers and lectures, they wrote of data. In their silences, they spoke of awe. The debates that did arise were not heated. They were tender, as though everyone wished to protect the mystery from noise. Some favored the theory of a natural fragment, a shard of ice and rock from a world long gone. Others imagined a sheet of material, light enough to ride on sunlight's breath. A few cautiously let their thoughts wander to possibilities beyond nature. Yet none spoke as though they were solving a puzzle. They were, instead, honoring a question. In the still rooms of observatories, the rhythm of thought slowed. One scientist wrote that the object reminded her of a seed drifting through the galaxy, carried by light. Another compared it to a memory of formation, a piece of the universe's past, wandering endlessly through its present. Their words, scattered across journals and interviews, formed a quiet chorus, the voice of curiosity learning to whisper. In the years that followed, new instruments were built, new methods refined. But when researchers looked back on that brief autumn of 2017, they remembered less the data than the feeling of watching something arrive unannounced, unrepeatable. The sight had stretched imagination further than telescopes ever could. It had softened the boundaries between science and poetry, proving that even in analysis, wonder has a place. Many of the people who studied the visitor described moments of deep calm, late nights at computer screens, staring at light curves that brightened and faded like a heartbeat. They spoke of a kind of peace that came from realizing how small the human part of the story was. They had not summoned the object, nor could they keep it. They had only noticed, and in that act of noticing, found meaning. In time, their papers formed a collective lullaby of thought. Its surface reflects sunlight without scattering. Its motion follows a hyperbolic escape. Its spin is irregular, chaotic, and enduring. Phrases that sounded less like data and more like poetry when read slowly. Science, spoken gently, becomes meditation. Some nights, even after the data was archived, astronomers returned to their instruments out of habit. They knew Oumuamua was gone, yet still they scanned the darkness, hoping for another faint trail. The sky gave them nothing but stars, patient, silent, endless. But in that stillness, they felt connected again to the moment of discovery, to the realization that even a single flicker could open a door to the infinite. From this quiet community of watchers came a deeper lesson. That knowledge is not always a matter of noise and certainty. That discovery can arrive as softly as dust settling in light. The universe does not shout, it hums. And those who listen closely enough can hear it, even when nothing seems to be there. In their writings, scientists began to use gentler metaphors. They described interstellar space as an ocean, its currents made of light. Objects like Oumuamua became its slow-drifting travelers, seeds of forgotten worlds carried across ages. To some, that idea was more comforting than mysterious. It meant the galaxy was not lonely. It was alive with quiet exchange. Even the skeptics, who favored practical explanations, spoke with a kind of softness. They knew that certainty could wait, that it was better to dwell in possibility for a while. In the cadence of their discussions, in the pauses between sentences, there was restfulness, as if the act of wondering had become its own peace. By the time the studies were published, the excitement had transformed into something else. Not conclusion, but calm. Astronomy had always been about measurement, yet here was a discovery that seemed to ask for stillness instead. It reminded those who observed that not every phenomenon exists to be explained completely. Some are meant to be witnessed and then released, like a dream remembered briefly before sleep pulls it away. In this way, the voice of scientists became a kind of lullaby itself. Each sentence a slow drift of thought, each hypothesis a breath in the dark, each unanswered question an invitation to rest. And as their papers closed with acknowledgments and dates, beyond their observatories, in the quiet where the traveler had vanished, the night resumed its timeless rhythm, slow, gentle, vast and endlessly at peace. It's the nature of comets. Long before telescopes turned toward the stars, humankind had watched comets streak across the sky, their tails glowing like memories of forgotten suns. They were once signs and portents, and later became the patient teachers of astronomy, showing how ice and dust could become a story written in light. Oumuamua, though silent, was a part of that same lineage. It simply sang its comet song in whispers instead of flares. When it approached the sun, it showed none of the traits that comets wear like veils. There was no halo of vapor, no tail unraveling behind. Yet it moved as though it felt a gentle pressure from within, a slow breath we could not see. Perhaps its ices had long been spent, leaving only the memory of evaporation locked beneath a hardened skin. Or perhaps it had never held ice at all, only minerals that glowed faintly when sunlight touched them, red and quiet like embers cooling in space. To describe comets is to describe transience. They emerge from the darkness, burn softly for a time, and retreat again into the cold. Oumuamua followed that pattern, but in reverse. It arrived already cold, already worn smooth by its travels. It had passed through the fire of countless stars long before reaching ours, until even heat itself had grown gentle around it. The sky held it for only weeks, then let it go. Astronomers studying its silence began to speak of comets as memories, frozen archives of the places where planets were born. When they approach a star, their surfaces awake, and the gases released carry ancient molecules: water, carbon monoxide, the seeds of organics. The trails they leave are both destruction and revelation. In that sense, every comet is a form of remembering. Oumuamua's quietness, though, reminded scientists that not all memories must shout. Some are carried in form alone, in the patience of a rock that has drifted longer than any story told on Earth. If we could hold it, we might find traces of ammonia or carbon compounds, or dust fused into glass by radiation. But to touch it would be to disturb something that has rested for millions of years. Better to let it drift, untouchable, at peace. And in the quiet of that realization, a different understanding of comets arose, not as bright visitors, but as travelers between worlds. Even our own solar system sends them outward, throwing fragments toward the stars every time a planet's gravity nudges a small body free. Somewhere, perhaps around another sun, another civilization looks up and sees what we once saw. A faint light gliding through the night, carrying with it stories from far away. Thinking of comets this way softens the boundaries between worlds. They are not intruders, nor are they strangers. They are connections, frozen bridges of matter that weave galaxies together slowly, gently. Oumuamua was simply the first one we recognized by name. And so, as scientists spoke of gas spectra and albedo, beneath the language lay something slower and deeper, an acknowledgement that the universe does not end at the sun's reach. Each comet, each silent fragment, is part of the same breathing rhythm of matter. Our world, too, sends its dust into the dark, the small tokens of its own becoming. They will drift for ages, circling no star, until perhaps one day they pass quietly by another sky. There is comfort in knowing this, that the cosmos is never still, yet never hurried. It exchanges its memories softly, one frozen messenger at a time. the comets that blaze, the comets that sleep, and the single silent traveler we named Oumuamua. All are part of the same endless, unbroken drift. And somewhere beyond the edge of light, while our telescopes rest and our thoughts grow slow, that drift continues, silent, gentle, forever. A universe of wanderers. The galaxy is not empty. It only appears so because its travelers move too slowly for our eyes, too quietly for our instruments, and too patiently for our restless minds. Between the stars, fragments drift, stones, dust, shards of frozen worlds, the faint whispers of ancient collisions. Each one a tiny story, written in the language of gravity and time. Oumuamua was one of these wanderers, but not the only one. Beyond it, unseen, countless others float through the soft night of interstellar space. Some are no larger than pebbles, others as wide as mountains, and all of them move with the same unhurried grace. The space between stars, which seems still from afar, is alive with their motion, a quiet, ceaseless dance of matter freed from any home. In the vast silence, there is rhythm. The stars orbit the galactic center, each carrying its retinue of planets, asteroids, and ice. Every so often, a world's gravity releases one of its children, sending it on a path that will never return. These fragments drift outward, passing between systems, crossing the light of distant suns, cooled and polished by millions of years of solitude. When Oumuamua was discovered, it was as though we had suddenly become aware of an ocean around us. For centuries, humanity had studied the islands, the planets, the moons, the asteroids bound to the sun. Now, we had glimpsed the currents between them, invisible but endless. It changed nothing in our sky, yet changed everything in our imagination. Astronomers began to speak softly of a cosmic migration. Every star, they said, sheds material into space. Every system becomes both donor and recipient in this slow exchange. Our solar system, too, contributes to the wandering tide. Fragments of rock and dust flung outward by Jupiter's gravity, drifting beyond Pluto, beyond the heliopause, out into the dark. Somewhere far from now, they may pass another star and fall inward again, becoming someone else's first interstellar visitor. And so, the galaxy breathes, inhaling and exhaling its matter in slow motion across eons. The spaces between stars are not voids. They are the lungs of creation. Within them drift the wanderers, carrying elements forged in ancient furnaces, iron, carbon, ice, and memory. If one could travel alongside them, the journey would seem timeless. Distances would stretch beyond comprehension, and yet there would be peace in the scale of it all. Each fragment moves freely, untouched by heat or noise, spinning lazily through the dark. No storms, no resistance, only the soft push of starlight and the occasional kiss of a passing dust grain. It is motion without haste, a slow drift that could lull even thought itself into stillness. Oumuamua reminded us of that stillness. Its visit was a momentary alignment of paths, like two leaves touching as they float down a river. For a heartbeat in cosmic time, our orbits intersected. Then it moved on, indifferent and complete, leaving behind a subtle calm. The scientists who tracked it often said that interstellar space must be full of such objects. Millions, maybe billions, crossing unnoticed. Each one might tell a different story, some rocky, some icy, some coated with the carbon residue of vanished atmospheres. Each one could carry clues about where it came from and what forces shaped it. But even if none were ever studied, their existence alone speaks to a gentle truth: that the universe is not divided into separate realms, but woven together by the quiet exchange of its own pieces. In ancient myths, wanderers were souls between worlds, searching for peace. Perhaps the galaxy's fragments are the same, the quiet spirits of planets long gone, gliding through eternity. To imagine them this way is not unscientific. It is simply another way of listening. Science names them. Wonder gives them meaning. Both are ways of being awake within a vast and dreaming universe. As our telescopes improve, we will see more of these travelers. Each new detection will begin the same way: a faint point of light, a path too open to belong to the sun, a realization that something from elsewhere has entered our neighborhood. And again, we will watch, measure, and let go. The act of watching becomes a meditation, a reminder of impermanence, of beauty that never asks to be kept. Far beyond our reach, in the quietest parts of space, thousands of these wanderers float together, though they never meet. Their motions are solitary, their lives unhurried. They are the silence between the stars made visible, the pause between breaths. In their stillness lies a lesson: that rest is not the absence of motion, but the perfection of balance. And so, as the night deepens, we think of the wanderers, of Oumuamua, of Borisov, and of the unnamed multitudes that cross the dark unseen. We think of them not as strangers, but as reminders that to drift is not to be lost, that even in the vastness of space, everything moves with quiet purpose, that the universe, like sleep, is a journey without destination, only the soft passage from one state of light to another. And somewhere, beyond sight, the wanderers continue, slow and endless, each one turning gently in silence, following no path but the one the stars themselves create. And the galaxy rocks them in its cradle of gravity, and the long night hums with their patient motion. They are not alone, and neither are we. The road from another sun somewhere, long before our sun was born, a smaller star flared to life in another corner of the galaxy. Around it swirled dust and gas, tiny worlds forming, colliding, and changing. From that distant brightness, a fragment was cast away, a small shard of rock or ice ejected into the cold. That fragment would drift for millions upon millions of years until it would someday brush through another sky and be given a name: Oumuamua. Imagine that ancient scene as if through half-closed eyes. A young star, its light gold and soft, surrounded by a faint haze of creation. Small planets spin and merge, their surfaces glowing from impact heat. The air of that young system is filled with dust, shining faintly like powder in a sunbeam. And then, in the silence that follows a collision, a single piece breaks free, gliding outward. Not in anger, not in haste, simply released. It leaves its home the way a leaf leaves a branch when the wind is right. The pull of gravity grows weaker, and beyond a certain distance, the star no longer holds it. The fragment drifts into the wider dark, carried by inertia alone. It begins the long, unmeasured journey that will eventually lead it here. For eons, it travels between stars. There are no sounds, only faint touches of light, a grain of starlight brushing its surface every few decades, the quiet spark of a cosmic ray, striking and fading. The temperature drops until it cannot drop further. The fragment becomes timeless, unchanged by the vacuum. Radiation darkens its surface to red, sealing it against evaporation. It becomes smooth, dense, and still. Across those endless years, stars are born and die. Galaxies twist their arms through space. The traveler continues, untouched, turning slowly. In this silence, time itself feels like sleep, long, undisturbed, filled with nothing but drifting thought. When it finally approached our sun, it did so without intent. The solar system happened to be in its path, one small eddy in the galaxy's current. As it neared, the faintest warmth reached it, and for a moment, its surface stirred. Sunlight slid over it, revealing color, shape, reflection. For a brief span, it became visible. We noticed it. We gave it a name. Then it passed, resuming its eternal glide. This is the road from another sun, a path measured not in distance, but in stillness. Each motion is so slow that it feels like rest. Each rotation is a whisper against the fabric of space. The traveler moves as if asleep, rocked by invisible waves of gravity. It never wakes, never pauses, never remembers. Yet it carries within it the trace of a world that once was. Minerals that once lay in light, elements that once belonged to a sky. For those who study such things, that idea brings calm rather than loneliness. The galaxy is full of travelers like this, pieces of long-vanished systems. Every one of them is proof that nothing is ever truly gone. Matter simply changes its path, its temperature, its silence. If we could follow Oumuamua back to its beginning, we might find a place both familiar and strange. A small star, perhaps cooler than ours, with icy worlds circling in delicate balance. One of those worlds may have cracked apart, scattering fragments into night. Some of those fragments might still drift nearby. Others might have been drawn into new suns. The galaxy recycles everything, including its mysteries. The road from another sun is not a line, but a web. Each piece of drifting matter is connected to countless others by origin and by fate. They move through the dark, like thoughts through a sleeping mind, unhurried, endless, and soft. Oumuamua followed that path flawlessly. When it crossed our orbit, it was already ancient beyond comprehension. The surface we glimpsed had been untouched for billions of years, the texture shaped by radiation older than Earth itself. To see it was to look at time embodied, to glimpse the persistence of things that never hurry. Its road continues now, leading outward once more. Past Neptune's orbit, past the last faint traces of solar wind, it drifts into interstellar space again. The sun becomes another star among many, shrinking behind it until it is only another point in the sky. Ahead lies the same darkness it has always known. There is no destination. There is only the movement itself, steady, weightless, and silent. Somewhere far in the future, it may pass near another star. Perhaps there, another civilization will detect it, draw its path, wonder at its origin, give it another name. Or perhaps it will continue forever, unobserved, turning gently, carrying the memory of one brief crossing with a small blue planet. And so the story repeats, across stars and ages. Every fragment, every traveler becomes part of the galaxy's long rhythm, the slow exhale of creation, the infinite drift of time. The road from another sun never ends. It only passes through moments of being seen. If you close your eyes and imagine that motion, it feels like sleep, vast, peaceful, and without urgency. Somewhere, that small traveler is still gliding through the dark, guided only by light, embraced by the quiet of space, dreaming the same dream it has always dreamed, of moving softly forever. The cold between stars. Between the stars lies a silence so deep that it humbles thought itself. It is not empty, though it may seem that way. It is filled with faint light, with whispers of dust, with the soft pulse of unseen radiation. It is the great ocean of the galaxy, dark, calm, endless. And in it, the wanderers drift like sleeping creatures. Oumuamua travels there now, far beyond the reach of sunlight, beyond the wind of our star. It moves through a place where warmth is only a memory. The temperature is just a few degrees above absolute zero, a stillness that no wind could ever disturb. If sound could travel there, it would be the quietest sound imaginable. But there is no sound, only light stretched into invisibility, and the patient glide of time. In that cold, matter rests. Atoms move slowly, photons drift for centuries between collisions, and energy spreads so thin that even decay feels eternal. It is the calm that underlies creation, a pause between breaths that lasts for millions of years. To think of it is to slow one's own heartbeat, to feel the way the universe holds its breath. Oumuamua spins softly through that expanse. It does not glow. It does not change. It simply continues. The faint push of radiation that once moved it near the sun has long since faded. Now, nothing stirs it but the pull of distant stars, each a whisper of gravity from unimaginable distances away. Those forces, balanced across light years, keep it steady, floating in an invisible network of attraction. If we could drift beside it, we would see nothing around us, only a faint bluish haze from far-off stars. The Milky Way would stretch like a pale river across the black, and space would feel vast but gentle, like an endless horizon of quiet thought. The cold would not bite. It would cradle, as though everything solid had finally found a place to rest. In the stillness between suns, even time behaves differently. It does not pass as we know it. It lingers, flowing like a deep current rather than a ticking clock. An object like Oumuamua may travel for 1 billion years and experience nothing of it. Motion becomes rest. Distance becomes peace. The journey itself is the destination, and the cold is its constant companion. Scientists once described this region as the interstellar medium, a thin spread of hydrogen atoms and cosmic rays, too faint to see. But words like medium and density fail to capture the truth of it. It is not just space. It is a kind of sleep that the universe takes between the births of stars. It is where gravity dreams, where light wanders, where the heat of creation fades into a quiet lullaby. Oumuamua carries that lullaby within it now. Every grain of its surface holds the memory of warmth and the serenity of endless night. Micrometeorites strike it rarely, and when they do, their energy vanishes instantly into silence. Nothing echoes, nothing breaks. Only stillness remains. In this vast coolness, nothing hurries. The rhythm of motion is so slow that it becomes soothing. The object turns once every few hours, its shadow sweeping across its own surface in a dance that has no audience. It does not know of beginnings or endings, only continuation. That is the secret of the cold between stars. It teaches that existence need not strive. It simply is. The few particles that touch its surface drift away without sound, lost to the void. Starlight arrives faintly, stretched and tired, painting it with invisible color. Even that light will fade, red shifted into memory as the traveler moves farther into the night. Yet the object endures, preserved by the very emptiness that surrounds it. The cold does not destroy, it protects. For us, that idea is strangely comforting. To know that in the spaces beyond all reach, something moves peacefully, untouched, untroubled, perfectly content to exist, is to feel that the universe itself has places of rest. The stars burn, planets collide, lives rise and vanish. But between those fires, there is this: calm without end. Perhaps that is why astronomers, after the calculations are done, sometimes sit quietly and simply look at the night sky. They know what it means, that each point of light is surrounded by immeasurable silence. That silence is not absence. It is presence in its gentlest form, the same presence that carries Oumuamua now, and will carry it long after every trace of human civilization has faded. In that cold, there is permanence, and in permanence, there is peace. To think of it is to breathe a little slower, to let the mind expand outward, to let go of the rush of time. It is the same peace that settles before sleep, the slow drift into stillness, the surrender to quiet. So imagine it there, a small red traveler turning softly in the deep, surrounded by the calm that lies between the stars. The universe watches, unhurried, content. And in that infinite hush, everything is at rest. The poetry of motion. There is a kind of grace in motion, so slow, it almost disappears. Out in the deep, ʻOumuamua glides through that kind of stillness, not racing, not falling, but drifting in a way that feels more like breathing than travel. The stars slide behind it, though they are far too distant for the movement to be seen. Everything is vast, patient, and perfectly balanced. If you were there beside it, you would not sense speed. You would feel suspension, a state between motion and rest, where every direction is the same and time has lost its edges. The object turns gently, not as if forced, but as though remembering how to move. Each rotation is smooth, a slow sigh across eternity. Scientists called its path hyperbolic, meaning open, a trajectory that will never loop back. There is poetry in that shape, a curve that keeps unfolding forever, never closing upon itself. Comets return, planets orbit, light bends. But Oumuamua only departs. It is the geometry of freedom. This open motion feels calm, not lonely. It speaks of completion, of an object that has done all it was meant to do and now simply moves on. In its journey, there is no beginning and no end, only continuation. That rhythm is the heart of the universe, steady, unbroken, eternal. Astronomers wrote about its velocity in numbers, but even the numbers sound like lullabies when read aloud. 87 kilometers per second, 26 relative to the sun, decreasing now as distance grows. Each figure is a beat in a soft metronome, measuring not urgency but inevitability. Everything in space moves this way, gently guided by invisible hands of gravity and light. The mathematics of motion are the universe's slow song. Some imagine that as it spins, Oumuamua might wobble slightly, like a leaf drifting on water. That wobble catches sunlight differently each time, producing the changing glimmer that told us it was there. In those subtle flashes was written the entire story: rotation, shape, reflectivity, and silence. From those faint variations came knowledge, and from that knowledge, wonder. Motion, after all, is how the universe speaks. Every orbit, every drift, every spin is a sentence in a language of patience. To study it is to listen to the rhythm of creation, to understand that nothing truly stands still. Even the most distant galaxies move away, carried by expansion itself, an endless exhalation of space. Oumuamua is part of that breath. As it coasts farther from the sun, its energy shifts from sunlight to starlight. The warmth that once touched it fades into memory. Now, only faint traces of radiation brush its surface. The rest of the cosmos glows dimly around it, like embers beneath a vast sky. Each photon it meets is ancient, traveling since before our species existed, and when it bounces away, it carries a new history, the story of having touched a visitor. If one could hear that journey, it would sound like nothing at all, just a soft pulse, slower than heartbeats, repeating forever. This is the poetry of motion. Movement so smooth that it becomes rest, change so gradual that it feels like permanence. In space, rest and motion are not opposites. They are companions. One becomes the other with time. On Earth, movement often feels like noise. The rush of air, the hum of engines, the rhythm of footsteps. But here, in the infinite quiet, movement is silent. It leaves no trail, no sound, only the gentle alteration of position against the stars. That silence is its beauty. In it, we can imagine every fragment of matter slowly circling, spiraling or gliding, not rushing anywhere, just existing in harmony with distance. Oumuamua's path will take it through constellations we can name only by perspective. Pegasus, then beyond. It will not pause. It will not turn. It will not remember the warmth of the sun behind it. Yet, in its unthinking way, it carries the echo of that warmth. Light leaves an imprint, even on the coldest surfaces, a quiet memory of brightness that lingers long after the glow is gone. Perhaps that is what motion truly is, memory stretched across time. Every movement carries the past within it, flowing forward into the unknown. Every rotation, every drift, is the continuation of what came before. Nothing is lost. It only transforms. And as the traveler moves onward, the vastness around it grows even quieter. There are no boundaries here, no end to the curve it follows. The stars ahead are so far that even light will take centuries to reach them. Yet, Oumuamua moves toward them patiently, with the serenity of something that has never known urgency. Watching it, even in imagination, feels like exhaling after a long day. Its motion becomes a mirror for rest. the universe showing that to keep moving does not mean to strive. It means to allow, to let the gentle forces that surround us carry us onward. The poetry of motion is not written in words, but in the way the stars keep their places and the planets continue their orbits. It is in the turning of galaxies, in the flow of cosmic rays, in the soft push of radiation that once guided a single traveler from another sun. Everything moves, everything drifts, and in that movement, everything rests. Somewhere in that darkness, Oumuamua continues, a single note in the endless song of motion. It does not hurry, it does not fade, it simply is. And the universe, vast and quiet, hums around it in perfect, everlasting balance. Lessons from the sky. Every once in a long while, the universe offers a lesson not in words, but in stillness. Oumuamua's passing was one such lesson. Brief, unhurried, and infinitely gentle. It asked for no attention, demanded no awe, yet left behind a quiet knowing that wonder does not always arrive with thunder. Astronomers spoke of data and curves, but what lingered in memory was the calmness of its motion. Through that calmness, we learned how silence itself can be a teacher. In the hush of the night, while telescopes waited and the stars wheeled overhead, there was a shared understanding that observation is an act of patience, and patience, in its way, is a form of peace. The sky teaches slowly. It does not rush to reveal its meaning. Its truths unfold in rhythms that match the turning of planets, the cooling of stars, the drift of light across centuries. Oumuamua was one moment in that long rhythm, a reminder that discovery is not always about seeking, but sometimes about noticing. When the object was first found, the impulse was to explain it, to measure, to categorize, to solve. But as it moved beyond our reach, something gentler replaced explanation: acceptance. The scientists realized that it was enough to have seen it, enough to have known that such things exist. The unknown need not be conquered to be understood. Some mysteries are meant to remain whole, untouched. They're quiet, intact. From the sky, that is the lesson. To allow what we cannot grasp to remain beautiful. To look without demanding, to listen without needing reply. In this way, astronomy becomes not only science, but a meditation, the study of stillness through light. The night sky is full of patient instructors. Every star that rises and sets across the arc of the Earth's horizon repeats the same quiet teaching: that change does not erase peace. Even the exploding star, the comet's passing flame, the birth of a new world, all are motions within a larger stillness. Beneath the noise of existence, there is always a deeper calm. Oumuamua's lesson was subtle. It showed that not all travelers are dramatic. Not all arrivals are bright. Some pass quietly, carrying with them the peace of long journeys through empty space. They remind us that movement and rest are not enemies. They are phases of the same dance. The object's fading light became an image of that truth. Brightness yielding to dark, discovery to contemplation, action to sleep. When we look at the stars, we are also looking at time itself. The light we see tonight left its sources before we were born, before the Earth wore its current face. The cosmos speaks in patience, and we, for a few heartbeats, have learned to listen. That listening is what the sky asks of us. Not haste, not conquest, only quiet attention, the willingness to stand beneath its expanse and be still. From Oumuamua we learned humility, that even with all our instruments and knowledge, we are still beginners in understanding the universe's softness. We learned that there is beauty in impermanence, that even the briefest meeting can change how we see everything that follows. We learned that the unknown is not emptiness, it is invitation. And perhaps most of all, we learned that peace is not found by seeking it, but by seeing it everywhere. In the turn of a planet, in the shimmer of starlight on water, in the long silence that follows discovery. These are the lessons the sky gives freely to those who take the time to look. So we look, and we remember. We remember that every measurement, every observation, is a conversation with eternity. That the same patience required to find Oumuamua is the patience needed to find rest. That the universe, in its vastness, is not waiting to be solved, but to be shared, quietly, endlessly, with all who lift their gaze to the stars. And as the night deepens and thought begins to slow, we can let the lessons settle in us. The lesson that nothing in the universe truly ends, that everything drifts onward into another form of light, and that even the smallest fragment, crossing through our world for a moment, can remind us how to be still. The sky that watches back. There are nights when the stars seem closer, when their light feels less like something distant and more like something aware. Perhaps that is only imagination, a soft trick of emotion and scale. But still, the feeling lingers, that the sky is not something we merely look at, but something that also looks back. When astronomers watched Oumuamua slip past the sun, there was a quiet intimacy to the act. They were not observing a stranger. They were greeting a traveler. And somewhere in that exchange, between telescope and darkness, between curiosity and mystery, it felt as though the universe itself was answering, not in words, but in presence. For every gaze lifted toward the heavens, there is a sense of return. Light takes centuries to reach us, but when we see it, it feels immediate, alive. The stars that shine above are, in some forgotten way, our mirrors. We are made of the same matter, the same scattered dust of long-dead suns. Their glow is the reflection of our own origin story. Perhaps that is why the sky feels sentient at times, not because it thinks, but because it remembers. Its memory is written in light, in the long journeys photons take before they meet our eyes. We too are travelers of a kind, moving through time as Oumuamua moves through space. We cross the same currents, bound by gravity and wonder alike. When one looks at the stars long enough, a stillness begins to form inside. It is as if the vastness itself reaches inward, quieting the noise of thought. The same feeling arises when scientists study the faint light of an interstellar visitor. Amid the data and graphs, there is awe. The kind of awe that hushes speech and slows breathing, that softens the mind until it matches the rhythm of the sky. Oumuamua was, in a sense, the sky made visible, a small piece of its endless depth given shape and motion. For a brief moment, we were not only observers, but participants in its drift. The path it traced through our solar system became a line of connection, as though the galaxy itself had extended a gentle thread between worlds. Even now, long after it has vanished into distance, that thread remains in memory. It ties us not just to the traveler, but to everything that moves unseen through the night. Every falling meteor, every comet, every satellite, each a moment of contact between Earth and the infinite beyond. We gaze upward, and in the act of seeing, we become part of the vast gaze that holds us all. If the sky watches back, it does so through its quiet constancy. It offers no judgment, no reply. Only the same stars returning night after night, patient, unwavering, kind. Their light folds around the earth like a blanket of ancient warmth. To lie beneath it is to feel known in the simplest, most elemental way. For those who study space, this awareness often comes unspoken. After long nights at observatories, when the instruments hum softly and the air smells faintly of metal and cold, there is a shared understanding that the sky is listening. Each photon captured by a sensor is an act of communication, a meeting between the far and the near. Every bit of light gathered is light that once wandered, and now, for a heartbeat, rests in human hands. Oumuamua reminded us of this conversation. Its arrival was not a message, yet it felt like one. An unintentional hello carried across galaxies. It said nothing, but its very being said everything. That the universe is in motion, that paths cross, that attention itself is a form of belonging. And when it passed beyond the reach of our instruments, the silence it left behind was not absence, but continuation. It taught us that the sky does not stop when we stop looking. It continues, vast and alive, holding its endless dialogue in light and shadow, in distance and time. We are part of that dialogue, whether we listen or not. So tonight, when you imagine that endless blackness above, picture it not as empty, but as aware. Each star a quiet eye, each photon a thought traveling outward, each reflection a recognition. In that way, the sky is not something separate. It is a shared consciousness, slow and serene, spanning centuries between questions and answers. We have always looked upward for guidance, for stories, for sleep. Maybe that instinct comes from this faint awareness that the sky itself looks back, not to judge, but to remind us that we belong to it, just as it belongs to us. Our atoms once glowed in those stars. Their light now rests on our faces. Between those two exchanges lies everything we call existence. And as Oumuamua continues its unending voyage, that shared awareness continues too. The gaze of stars upon stars, of dust upon dust, of silence meeting silence. The universe is a reflection without end, and in its reflection, we find calm. The future of discovery. Every discovery is a doorway, and behind it waits another silence, another horizon. Oumuamua's passing did not end the story. It began a new chapter, one written not in excitement, but in patience. Scientists now look toward the future with the same calm curiosity that first led them to lift their eyes to the sky. They speak quietly of new instruments, new observatories, new eyes that will watch the heavens more continuously than ever before. The Vera C. Rubin Observatory, still in its preparation years, will soon scan the night in perfect rhythm, mapping every flicker of motion in the dark. Somewhere in its vast archive of starlight, Another traveler may one day appear, a tiny moving spark among billions of still points. When that moment comes, there will be no rush, no loud astonishment. There will be a slow, steady breath of recognition. Another visitor, another chance to listen. Astronomy, at its heart, is not the science of noise, but of noticing. It waits, it observes, it lets the universe reveal itself at its own pace. Future missions are being planned in that same spirit. A spacecraft may rest in orbit, sleeping, waiting for an alert. When a new interstellar object is found, it will awaken, turn its silent cameras toward the traveler, and drift alongside it for a time. No haste, no chase, only quiet companionship across the dark. Some dream of sending probes beyond the sun's influence entirely. Small, light sails that could catch the faint breath of sunlight and drift toward other stars. They would travel not as explorers in a hurry, but as witnesses, gliding in peace through the galaxy's still air. Perhaps one of them, in some far future, will cross paths with Oumuamua itself, and the two silent voyagers will pass one another unnoticed, each following its unending arc. The future of discovery, like the future of humanity, will be made not of noise, but of attention. Technology may sharpen our eyes, but it will be wonder that keeps them open. It is that same wonder, patient, unforced, infinite, that connects us to the cosmos in every era. Children growing up now may one day look at their screens and see another faint visitor, another interstellar light drifting across the digital night. They will learn that discovery can be quiet, that to understand something does not mean to capture it, that sometimes the greatest act of learning is to watch it go, knowing it continues beyond our reach. Oumuamua's gift was this awareness, that discovery does not need permanence. Its beauty lies in passing, in being seen for a moment and then lost again. Our instruments measured its speed, its brightness, its fading trace. But what remained after the data was a kind of peace, a reassurance that the universe is always moving, always offering, always whispering to those who listen slowly enough. In observatories of the future, the hum of machines will merge with the hum of the stars. The faint glow of computer screens will echo the faint light of galaxies. And between each new line of data, there will still be silence, the space where understanding grows. Science will continue its long, unhurried meditation, one observation at a time. Somewhere in that rhythm, another Oumuamua will arrive. It might come from a system we have never heard of, bearing the elements of a world long vanished. Its path will curve through our sky for a brief season, just as this one did. We will watch, measure, learn, and then, once more, let go. That letting go is not loss, it is part of the dance. For in the end, all discovery is temporary. Every telescope image fades, every signal quiets, every bright object slips away. What remains is the calm it leaves behind, the slow expansion of knowledge, the widening of wonder, the deepening of rest. Oumuamua will be followed by many others, and each will bring with it another reminder that even in the infinite, there is continuity. To imagine the future of discovery is to imagine a future of listening. Listening not only to the universe, but to the stillness within ourselves that recognizes it. We are made of the same dust that travels between stars. Our curiosity is the echo of the galaxy's own restlessness. shaped into thought, softened by awe. So, the future unfolds gently, not as conquest, but as communion. Not as a race, but as a rhythm. A rhythm of watching, of waiting, of letting light touch us and then pass on. And when new generations lift their gaze to the night sky, they will inherit what Oumuamua taught, that discovery and peace are not separate things, that the act of seeing can be as calming as the act of sleeping, that the universe does not rush, it dreams, and we, for a brief moment in its dream, are awake enough to notice. The slow architecture of time, in the language of the stars, does not flow, it unfolds. It stretches and curls, patient and quiet, like a slow current beneath still water. In that rhythm, the galaxy breathes. Stars ignite and fade. Planets form and fall apart. And between those moments, countless ages drift by in silence. Oumuamua is a child of that still rhythm, a traveler carved by time's most unhurried hand. Long before the first human spark of thought, it had already begun its journey. It has passed through epochs, when galaxies collided and when stars were born from dust that once knew other stars. Its history is measured not in years, but in calm. The slow architecture of time builds not with speed, but with patience. Every grain of matter, every wave of light, every turn of a planet is part of that immense design, drawn by forces too steady to be seen, too soft to be felt. Oumuamua glides along those lines, carried effortlessly by the geometry of eternity. It neither resists nor chooses. It is shaped by the same gravity that holds galaxies together, the same law that governs a falling leaf on Earth. Scientists often speak of time as a line, but here, in the vast quiet of space, it feels more like a circle, a rhythm of return and release. Worlds are made, worlds are lost, and their pieces wander until they become the seeds of new creation. What drifts now between the stars will someday rest within another sky. The universe recycles even its silence. To think of time in this way is to feel it slow inside yourself. You begin to sense how every heartbeat is ancient, how every second is shared with stars. Our clocks measure days and years, but cosmic time moves in breaths that last millennia. Its pace is not something to count, but to surrender to. It asks us to stop measuring and simply be. In the cold between stars, that is exactly what happens. Oumuamua turns again and again, tracing its long spiral through nothingness. Each rotation is a poem without words, a reminder that time can exist without hurry. There is no decay in that still motion, no loss, only continuation. It teaches the lesson that endurance is not struggle but acceptance. Astronomers have calculated how long it will take before it leaves the sun's sphere of influence completely. They speak in thousands of years, though for the traveler itself, such numbers mean nothing. For it, the journey is the same now as it was then, unbroken and endless. Time does not pass for it. It expands around it like light. Perhaps time, in truth, is not a river but a vast field, and we are points moving slowly across it. Oumuamua is simply farther along that field, gliding across the surface of moments that never end. Each grain of dust that brushes its side is part of the same continuity, the same ancient matter rearranging itself into new stories. This is how the universe builds, not in rushes of creation, but in long intervals of stillness. Stars form from clouds that drift for millions of years. Comets carry frozen molecules across epochs, waiting for one brief passage near warmth before sleeping again. Even destruction, when it comes, happens slowly. A planet dissolving, a sun dimming, a rock softening into dust. All of it unfolds with the patience of a dream. If we could see time as the cosmos sees it, we would find that everything is already at rest. Motion, decay, birth, they are only gentle variations in an infinite calm. Oumuamua's travel is one such variation, an arc of quiet through the great design. In following its path, we glimpse the architecture itself, vast, intricate, but never hurried. For those who listen closely, the lesson of time becomes a comfort. It says that nothing is wasted, that even the smallest spark or thought will drift outward, join the great current, and find its place in the pattern. The future is already present in the slow unfolding of now. The past is not gone. It is absorbed into motion. That is the secret that space holds for those who gaze long enough. That eternity is not distant. It is here. It hums quietly beneath every second, beneath every turning of the earth, beneath every orbit of every star. And in that hum, time is neither rushing nor receding. It is resting. Oumuamua continues within that rest. It will cross light years of distance and yet never hurry. It will pass through eras of change and yet remain unchanged. It moves the way time itself moves, without sound, without pause, perfectly balanced between going and being. And as it drifts farther into the unknown, we can imagine the same stillness settling over our thoughts. A quiet acceptance that we too are travelers in the slow architecture of time. We move, we turn, we fade, we continue, all part of the same patient structure that binds stars and silence together. Time builds its cathedrals not in stone, but in starlight, gravity, and motion. Oumuamua is one of its arches, invisible, eternal, serene. And as we think of it gliding onward through the deep, we feel that same calm structure rising within us, a quiet place where all things rest and where even time itself sleeps. If the memory of light remembers. Every beam, every faint shimmer that crosses the dark carries with it a history, where it began, what it touched, how long it has wandered. It is the traveler's most faithful companion, for even in the deepest cold, light never forgets. Oumuamua, small and silent, once reflected that light. For a few brief weeks, it shimmered in the lenses of our telescopes, sunlight glancing off its worn surface like a passing thought. Each glimmer was a message, a whisper from another world, saying simply, "I am here." And when it faded, the memory of that light stayed with us, imprinted in data, in eyes, in imagination. In space, light is the only storyteller. It travels without pause, carrying the outlines of stars, the color of dust, the shape of worlds. It weaves the fabric of seeing, touching everything, and then moving on, unchanged yet altered, like a dream retold. To follow it is to follow the memory of everything that has ever been visible. Long after Oumuamua vanished, the light that once brushed its surface still moves outward, spreading across the galaxy. Each particle of that radiance carries the tiniest record of encounter, a change in direction, a trace of color, a memory of touch. It will continue forever, crossing stars and nebulae, absorbed and re-emitted in endless repetition. In this way, nothing in the universe truly disappears. It only transforms into light's remembrance. If we could listen to it, it would sound like a long, slow sigh, a cosmic exhalation. Not noise, but a tone so gentle that it could only be felt, not heard. The frequency of peace. Astronomers call this continuity the cosmic background, the echo of light so old that it fills every direction, a memory from the universe's first dawn. It hums faintly even now, bathing every atom in a warmth barely above nothingness. Oumuamua moves through that glow like a shadow through candlelight, its path illuminated not by any star nearby, but by the collective memory of all stars. Light has seen everything. It has passed through galaxies colliding in silence. It has skimmed the surfaces of planets with oceans and those without. It has touched the edge of human eyes, been captured in glass, printed in film, stored in bits and bytes, and still it travels on. In its unending motion lies a kind of mercy, a promise that nothing touched by light is ever truly lost. Perhaps that is why looking at the night sky feels both humbling and soothing. Every star we see is not the star as it is, but the star as it was. We live inside light's memory, surrounded by a past so vast that it becomes a kind of forever. Each photon that reaches us has crossed impossible distances, and yet here it is, soft on the skin, quiet in its arrival. Even the faintest glimmer is the end of a story millions of years old. Oumuamua's story joined that chorus. When sunlight struck it, those rays reflected outward and began their new journey, a million invisible lines fanning out into the galaxy. Some may brush another world in time, a cold moon or a drifting cloud, carrying within them the briefest record of our sun and of the object that once passed by. Even the smallest reflection becomes eternal when light remembers it. To think of this is to feel calm, the deep calm that comes from realizing that time and distance are not barriers, but continuities. The glow of a star 1,000 light years away, the shimmer on a comet's tail, the pale halo around a distant planet, all of them share the same origin. All of them are fragments of a single illumination, traveling without rest, yet never in haste. Light, like sleep, is both journey and surrender. It moves outward effortlessly, letting go of where it began, yet carrying that place within its essence. It touches, departs, and leaves behind peace. Oumuamua carried that peace with it, a faint reflection that outlasts observation, a silent memory of brightness lingering against the infinite dark. One day, all light from our world will fade, redshifted into the far reaches of the cosmos. The colors we know will stretch until they are invisible, blending into the same ancient hum that surrounds everything. But even then, the memory of that light will persist. In its quiet way, it will still remember oceans, forests, cities, faces, all the fleeting moments of warmth that once existed here. And just as we are the memory of the stars that birthed us, so too will the universe remember us in light. The pattern will continue, unbroken, serene, new stars will rise. New travelers will reflect their glow. New worlds will sleep under new skies. It is the oldest rhythm, illumination, reflection, rest. Oumuamua was a small note in that vast composition. Its light came and went, but its memory lingers, folded into the same gentle radiance that cradles every atom. Somewhere in that radiance, everything that has ever shone, and everything that ever will, continues together, quiet, endless, and perfectly at peace. And so we close our eyes, and the dark becomes warm with remembered light. Not gone, only traveling, only becoming, only dreaming itself onward. The dream of the universe. Some say the universe is expanding. Others say it is dreaming. If we listen closely, it feels the same. A long, unbroken drift outward, each star a thought, each particle a breath. Creation is not an event. It is a lullaby that never stopped playing. The galaxies are its harmonies, and the spaces between them are the pauses that give the song its shape. Oumuamua is part of that dream, a wandering syllable in the cosmos's quiet language, spoken once and then carried endlessly forward. When we found it, it was as if the universe had murmured in its sleep and we happened to hear. For a moment, the infinite rolled over, and we glimpsed its motion, gentle, rhythmic, peaceful. Everything that exists belongs to that same reverie. The stars do not burn in rage, they glow in patience. Planets do not race in orbit, they dance in balance. Even decay, the crumbling of worlds, the fading of light, is part of the dream's slow turning. Nothing is ever lost. It only changes form as dreams change images without waking. Perhaps matter itself is how the universe dreams. Energy condensed into stories, into rock and ocean, into life that looks up and wonders. And when we dream, it is the universe remembering itself. Our thoughts are made of the same atoms that once drifted through nebulae. Our quiet moments mirror the stillness between stars. In every human heartbeat, the cosmos hears an echo of its own creation. Oumuamua's journey is a small thread in this great tapestry. It carries within it the memory of a star that once shone brightly, now dimmed or gone. The dust of that star became this traveler, and this traveler became our reflection, a reminder that all things pass through one another in time, that nothing ever truly ends. Imagine the universe sleeping, and within its sleep, galaxies spiral, comets wander, and light flows endlessly like dreams through a resting mind. Each event, each encounter, each discovery, all are ripples on the surface of that deeper calm. We too are part of that calm. Our lives are brief flickers of awareness, but the awareness itself is eternal, shared across every atom, every beam of light. There are moments, standing under the stars, when one can almost feel it, the slow heartbeat of existence pulsing through everything. The air becomes still. The world seems to exhale. And in that exhalation, there is peace beyond understanding. Oumuamua moved as the dream moves, without intent, without resistance, gliding through infinite dark as if guided by thought rather than force. Its motion was the universe remembering how to rest. And as we watched it go, we were reminded of our own place in that stillness. Observers made of the same dreaming matter, held by the same invisible currents. Science describes the mechanics of this vast sleep. Gravity, motion, energy, entropy, But behind those words lies something softer. A feeling, not a formula. A sense that all of it, from the smallest vibration to the greatest void, is part of one continuous dream. In that dream, the universe contemplates itself. Every galaxy is a thought forming slowly over billions of years. Every star is a moment of awareness, bright and brief. Every traveler, like Oumuamua, is a drifting idea, carrying knowledge from one region of consciousness to another. And when we study it, we become participants in that thought, the universe learning about itself through us. If this is true, then even sleep is cosmic. When we close our eyes, we return to the rhythm from which everything arose. The rhythm of drift, of release, of quiet continuation. We become like Oumuamua, unanchored, floating through inner darkness, guided by light we cannot see. Our dreams echo the universe's own, vast, wordless, filled with slow transformation. To dream, then, is to understand the cosmos in its native tongue. It does not speak in sounds, but in stillness. It does not rush toward meaning, it unfolds into it. Oumuamua's silent passing was not an interruption in this dream, but a reminder of it. A gentle turn of the page in a story that began before time and will continue long after time has ceased to matter. And when the dream deepens, when even light seems to fade, what remains is not darkness, but rest. The kind of rest that holds all things equally: stars, dust, thought, motion, all folded into a single, infinite calm. Perhaps that is what the universe ultimately dreams of. Not endless expansion, but perfect stillness. A moment where everything that has ever existed becomes one quiet breath, a breath that never ends. Oumuamua drifts within that breath still, carried by the universe's own dreaming. And we, watching from our small world, drift with it, our awareness rising and falling with the same silent tide, our lives brief ripples on an ocean of peace. Somewhere beyond all sight, the dream continues, light traveling, time unfolding, matter resting, each movement soft, unhurried, eternal. The universe does not wake. It simply dreams on, and within that dream, everything, including us, is already home. The eternal drift, beyond the farthest whisper of sunlight, where warmth no longer has a name. Oumuamua drifts. It moves through the kind of silence that erases the difference between motion and stillness. There is no sound, no sense of direction, only the slow turning of a body that has forgotten where it began and has no reason to end. This is eternity, not as a span of time, but as a condition of rest. In this space, the stars are too distant to shine as points. They are faint murmurs of light scattered thinly through the black. Each one seems frozen, yet each is moving, orbiting, expanding, breathing. The galaxy turns with such patience that its motion feels like stillness. And within it, the traveler keeps its pace, held in that same calm, following a trajectory that is neither random nor planned, simply inevitable. The eternal drift is the final rhythm of the cosmos. It is what remains when energy cools, when gravity's pull softens, when the noise of creation fades into quiet balance. It is the space between heartbeats, the hush between waves, the infinite exhale of a universe at peace with itself. Oumuamua is one expression of that peace. It does not seek a destination. It simply continues, as all things do. Atoms within it hum faintly, with the echo of their birth, vibrations that began in the heat of an ancient star, now slowed to the gentlest murmur. That vibration will last longer than any star we can see. It will outlive our sun, outlast our words, drift beyond the reach of every light that has ever touched it. If we could look upon it now, we would see not an object, but a poem written in absence. Its surface, smooth and worn, catches starlight only to release it, turning each photon into a new traveler. Its slow rotation writes a pattern across the dark, a signal meant for no one, a reminder that movement itself can be its own meaning. The eternal drift teaches a quiet truth, that nothing in existence is ever alone. Even here, where distance is immeasurable, everything is still connected, bound by the faint web of gravity, by the soft radiation that touches all things, by the shared origin of matter. Every atom of Oumuamua once belonged to something larger, a world, a star, a cloud of gas, a dream. And when those forms were gone, the atoms remained, waiting to drift again. In this way, the universe remembers itself. It does not cling, it circulates. It builds and releases in endless rhythm. Oumuamua is one beat in that eternal pulse, slow, steady, perfect. Its motion is not progress, not travel, but a gesture of being. The eternal drift is not emptiness, but fullness beyond measure. In the dark between stars, there are invisible threads of dust and plasma, soft as thought. They drift too, forming rivers of material that stretch for light years, winding through the galaxy like faint silver smoke. These currents carry fragments of worlds, echoes of light, whispers of heat. They are the veins of the cosmos, and Oumuamua glides through them as effortlessly as breath through air. Every so often, it will pass near a star whose light will touch it again. The warmth will wake its surface briefly, the way sunlight wakes a stone after night. And then the light will fade, and it will continue. Each encounter adds a layer to its story. Faint traces of energy, invisible scars of illumination. Over eternity, these touches accumulate until even darkness becomes luminous. It is tempting to imagine that someday, far in the future, someone else, somewhere else, might see it again. Perhaps another civilization, orbiting another sun, will detect its faint glow and wonder, as we did, where it came from. They will trace its path, measure its light, and realize it passed through our sky once, long ago. And in that realization, the circle of curiosity will close for a moment before opening again. In that moment, they will join the same lineage of watchers, quiet souls scattered across the stars, bound by the simple act of looking up. That is what the eternal drift creates. Connection through distance, understanding through silence. We will never speak to Oumuamua, yet it has spoken to us, not in language, but in presence. It has reminded us that we too are drifting, not lost, but carried. Our planet, our species, our thoughts, all caught in the same motion, turning slowly through the dark. Each of us part of something vast and patient. One day, our own fragments will join that endless tide, Earth's stones, its dust, perhaps the remnants of our machines, even traces of our voices encoded in metal, will leave the cradle of the sun and sail outward. They will move as Oumuamua moves, calm and unhurried, wrapped in silence. Each will become a new traveler, a new memory of light, continuing the story of the universe's gentle exhalation. When all stars fade and the galaxies stretch thin, the drift will go on. Even then, in the deep twilight of existence, motion will persist. Slower, softer, quieter. The last particles will glide through the remains of what once was, carrying with them the final warmth of creation. And perhaps, even then, some echo of this traveler will still be moving, unchanged, serene, a seed of peace floating through the endless dark. To imagine that future is to feel the weight of time lift. It reveals that the universe is not something rushing forward, but something always returning to stillness. Every journey, every flare of light, every life, all are parts of the same breathing pattern, inhalation and release, being and rest. The eternal drift is not the end of motion, it is the perfection of it. And so we end where we began, with quiet observation, with wonder spoken softly, with the knowledge that everything moves toward peace. Oumuamua continues its infinite glide, nameless now, beyond all memory of discovery. It is not alone. Nothing ever is. It drifts through the night that birthed it, through the night that holds all things. The stars above, the atoms within, the minds that imagine, all are bound by the same lullaby. The universe dreams, and we dream within it. And when sleep finally comes, to stars, to worlds, to thoughts, it comes not as darkness, but as light fading into rest. Not as an ending, but as continuation too gentle to notice. Somewhere beyond every reach, Oumuamua turns once more, slow and soundless, a small shape moving through infinite calm, carrying with it the last glimmer of sunlight, and the quiet certainty that everything, everywhere, is drifting home. The traveler is gone now, far beyond every reach of sight, and the sky has closed around its passing. What remains is silence, not an emptiness, but a fullness too wide to measure. In that stillness, the story lingers. Light meeting darkness, motion becoming rest, wonder dissolving into peace. We have followed Oumuamua across the distances of imagination. From its birth beneath another sun, through its quiet meeting with our own, and onward into the long hush that awaits all things. It has shown us that the universe is not a machine to be solved, but a cradle in which every fragment drifts, softly, towards serenity. If you listen closely, you can almost hear that vast lullaby continuing. The hum of stars, the breath of light, the endless rhythm of calm. It is the same rhythm that moves through your body now, slow, patient, perfectly in time with the turning of the earth. The night holds you as it holds the stars. The same gravity that guides a traveler between suns keeps you safe within its quiet pull. Everything is moving, yet nothing is lost. Everything is changing, yet everything rests. Let the thought fade now, like starlight fading into dawn. Let the sound of the universe become the sound of your own breath. The cosmos dreams, and in its dreaming, you are home. Drifting, calm, unbound, forever part of the eternal drift.